We're going to consider factoring special cubics similarly to the quadratics you have considered in the past, such as the difference of squares, a squared minus b squared. How we know that that gives us a minus b times a plus b. And we also should be familiar with the fact that a squared plus b squared is not factorable. In other words, there are no two things that we can multiply to give us the answer a squared plus b squared. So we're going to consider similarly for cubics, looking at the sum of and the difference of cubes. So the sum of cubes would be something like a cubed plus b cubed, and the difference being a cubed minus b cubed. So we're going to use our knowledge of the factor theorem and dividing polynomials to find the general factors of these two things. We'll start with the difference of cubes, and it should be pretty clear to us here that if a equals b, then we will get 0, right? If a and b are equal, then we are basically of a cubed minus a cubed, which subtracts out and becomes 0. So that indicates to us that a minus b is a factor. So we should be able to get this to be something like a minus b times something else. So we have to figure out what the something else is. So we're going to take a look at some division here. So a minus b is our divisor, and we have a cubed minus b cubed as our dividend. So I think we need an a squared, and a squared times a is a cubed. A squared times negative b is negative a squared b. A cubed minus a cubed is 0, and then we get 0 minus negative a squared b squared, so we're left with a squared b. And the only thing left here is that. It looks like next going to have to do plus ab, because ab times a gives us a squared b. And then we have minus ab squared. This part goes to 0. And so we have ab squared minus b cubed. And that means that I'm going to put b squared here, as b squared times a gives us ab squared, and then minus b cubed, which is in fact 0. So there we have proof that it is a factor, and the second part of the second factor here is a squared plus ab plus b squared. So here are my two factors. So what I have to figure out now is whether or not this here is factorable. So a squared plus ab plus b squared. Now, the only way I can end up with a squared and b squared on there would be to try doing a plus b squared, because that gives us a squared as the first term and b squared as the last. But in between, you'd end up with ab plus ab, right? So in here is plus 2ab, which is not the same as our factor. So it looks pretty much like that part's not factorable. We actually can verify it using the quadratic equation. So you could double check whether or not you can get an answer. I trust kind of what I've got here so far, and if you don't trust me, well, check out the quadratic equation and you'll find it has a negative, that this part under the square root in it will be a negative number, so it's not square rootable. Sorry about my phone ringing in that last slide. I'm really tired of those calls from "You've won a cruise," because apparently our grandparents fall for that. By the way, teach your grandparents not to fall for those. Okay, so now we're going to look at the sum of cubes. So we've got a cubed plus b cubed. So we're trying to figure out a factor for this here. If a is equal to negative b, I think we get 0. So it looks like a minus b should be a factor. So we should be able to write this as a minus b times some factor. So we need to figure out what that factor is going to be. Perhaps I'll leave some proper space here, and we'll actually put these in case you had trouble following on the previous one. So those are zeros, right? Those coefficients. I'm putting zeros there because there aren't any. And let's see what happens when we divide. So a cubed divided by a is a squared. A squared times a is a cubed. A squared times negative b is negative a squared b. If I do my subtraction, I get a squared b. And it's plus the 0 ab squared here. So this looks like I need to do a times b. A times b times a gives me a squared b minus ab squared. And of course, I've just realized I've made a mistake here, because this should have been a plus b, because I said when a is equal to negative b it works. My bad. So this should have been positive, which makes this negative, which means this needed to be negative, and that will make this one positive. Okay. And that means this is minus ab squared, and I'm bringing down the plus b cubed. So here I will have to have minus b squared what have I done here? Oops. Sorry, this should have stayed negative, which means this is positive. So this is positive. Plus b cubed, so that does leave us with 0, which means it is in fact a factor. So I've got a squared minus ab plus b squared. And again, right, so we're just putting this up here. So again, we'd have to double check to see if now this is factorable or not, right here. Because if it's factorable, then we can factor it further. And I mentioned before, we can generally verify this using the quadratic equation. So I'll write it in a slightly more familiar way for you, just in case you're unsure. I'll rewrite it with x instead of a. So x squared minus bx plus b squared. So let's put that into the quadratic equation. And if we're just going to verify it's not factorable, let's assume that for now. Let's just look at the square root part. So we know that part is b squared, and negative b squared is still just b squared, minus 4ac. 4a is 1, right? There's nothing there. And c is b squared. So this is the square root of negative 3b squared. And since b is positive regardless of what number it is, then this whole thing in here is negative. So this is undefined, which means that our factor up there is not any further factorable, so we are finished with a times b, or a plus b times a squared minus ab plus b squared.